Sorry, I've switched off the video because the light from behind is very bright. That's why that glare will come on the screen. That's why I'm switching off the video. So when screen sharing is there, I'll share it with you. Before that, can you just introduce who all are there? Because I think Prithviraj and Arun are from the previous batch itself. So other people I think are new students. So can you just tell me about your work experience or something like that, just to introduce yourself to know who all are there.
Yes, ma'am. I'm Arun Kumar.
Yeah, tell me.
Can you hear me?
Kirtik, right?
No. I'm Arun Kumar.
Yeah, tell me.
Can you hear me?
Yes, I can hear you. No problem.
Okay. I have done my engineering in electrical and electronics.
Okay.
I just want to know this electrical course technically. So I'm joining this.
Sorry, you want to know electrical?
The electrical, this design course fully technically, ma'am. So I can. So that's why I'm interested in this course.
Okay, fine. But so you are also BE electrical, right?
Yes, ma'am.
Okay, fine. So yeah, next person.
Hi, ma'am. I'm Kirti I'm from Qatar. I'm working CBM maintenance. Before I'm a HVAC student in Dharmasa, from Dharmasa.
Okay. So you're BE?
Yes, ma'am. I'm BE.
Okay, so that was mechanical or electrical?
Mechanical.
You are mechanical student, BE mechanical,
yes,
right? Okay. So just I wanted to know regarding your experience and your expectation. That's why I asked you for that introduction. Prithviraj and Arun VK, I know both of you. So that's why.
Another one person, Mr. Prakash, is there, madam.
Okay. I didn't see it on the screen. Hello?
I think Prakash in unmute. Why? Because he is in Mumbai.
Okay.
Today cyclone is there, no?
Yes, I know.
So that is the reason. I don't know whether he is speaking or not. Prakash, are you hearing me?
Yes, I'm getting you, sir.
Yeah. Please introduce yourself now.
Okay. Thank you.
Hello, Prakash. Okay,
He's in unmute, madam. You can start your class.
Okay, fine. Okay. This class basically is the first introduction regarding to the outline of the power system and the power generation, the power distribution, and the power transmission system. So you all know that electrical power, there are 4 stages, right from the stage when the power is generated to the stage when the power is used by the consumer. Okay, so I'll just start sharing. Dharma sir? Hello, Dharma sir?
Yes, ma'am.
Sir, the screen sharing seems to be disabled.
Yeah, is there, madam? Actually, in below that, mute, start video, share is there, no?
Yeah, share screen is there, but it is showing me one message like host disabled participant screen sharing.
Okay.
I think you have to enable it.
Yes,
from your side then, sir.
Now you can try, madam.
Okay, are you able to see the screen, all of you?
Yes. Now it's loading. Yeah.
Okay.
Yes.
Okay. So if you look at this, like I told you, the 4 stages in the electrical power, right from the point it is generated to the point where it is utilized. Can you just unmute your from your side, because otherwise the background noises will come in.
Okay.
If you have a doubt, no, just type in the comment in the chat box, or then I will stop and you can ask the doubt. I'll clear it, and then only we'll proceed. If any doubts are there, just put a message in the chat box. That's all. Okay. So we'll continue. Okay. So the generation, transmission, distribution and utilization of power. These are the 4 stages involved in the electrical power system total. Like if you see the next image, can all of you see? I hope it's clear to all of you. The red part, whatever is shown here, is the point of power generation. Okay, that is our generating station. So generating stations are of various types, you know, hydel power plant, thermal power plant, nuclear power plant, etc. All that will be coming under this category of generation, which is shown in red in this image. Okay, is it clear? Okay, so, and once the power is generated, generally what is the voltage at which power is generated? 11 kV, right? So once the voltage is generated at 11 kV, it has to be transmitted from this point of generation up till the final end consumer. Now, who all are the final end consumers? End consumers means it will be like if you see the bulk consumers will be there, as well as the domestic consumers will be there. We all will be coming under the category of domestic consumers. So in this drawing, the red is the generating part of the power transmission system, of the power network. The blue is how the power is carried from the generating part to the consumer part, that is called the transmission system. And finally, it is the distribution. Once it reaches close to the customer, how it is branched out to individual customers. Okay, so individual consumers, we have many types. One is the consumers who consume the heavy load. Who are the consumers who consume the heavy load? Mainly the industries, right? So the industries are consuming one type of load. Now, the another type of load that our people will consume is the domestic load. Like we all are domestic load consumers. So here what happens is that the voltage that is coming at this secondary distribution substation, primary distribution substation, is again switched down to a voltage that can be used by the domestic consumer. So like I told you, the above 2 ones which you see are the industrial customers or the bulk consumers. So they will use it at a different voltage, more than 415 voltage. But we, the domestic consumers, will be using voltage at what voltage level? If it is a 3-phase supply, we will be going with 415 volt. If it is a single phase supply, we will go with 230 volt, correct? Slightly, there will be slight variations depending upon the country where this will be used. What we are saying is just for India, okay? So in some countries, 3-phase, they will use 400 volt. Here we are using 415. Like that, small variation will be there, but some more or less the range will be the same. Okay. So that is the thing. So in this drawing, it is very clear, since we have categorized it as red, blue, green, and black, which part of the power system is focusing on which role. That means the red is the generation, the blue is the transmission part, and this is the distribution part, and black are the ultimate consumers of power. Okay, is it clear to you? So can you just, if you have any doubts, just go on, type that in the chat box, no issues. Whatever you have a doubt, we'll just clear it here itself. Or shall I proceed? If I can proceed, just put okay in the chat box. If you want me to explain this thing once again, That also you can put. Okay, so shall I proceed? Okay, I don't know, I'm not getting any messages from your side, but I hope it is clear to you. Anyone has any doubt, just feel free to stop me in between. Put that doubt in the chat box. We'll discuss on that, then only we'll proceed. Okay, so okay, just can you unmute it for 1 second and let me know if I can proceed?
Yeah, yes, ma'am.
Yes,
We have
yes,
sent a
ma'am.
message also.
It's not coming for me. Okay. I think here. Okay, fine. Okay.
Okay.
Okay, fine. Okay, this is fine. If at all you want me to stop, just put in the message. I think we can clear that there itself. Or if you want, you can unmute in the middle itself and tell me that you have a doubt here. I'll stop it, clarify, and then only I'll proceed. Okay? Okay, fine. Okay, so this is the same drawing, but with a little more of elaboration, like the power plant here. And if you notice here, the voltage that is mentioned is 11 kV or 33 kV. Why? Because the voltage that will be generated here, if you see, this is a step-up transformer which is there inside the substation itself. This is the part where the generator will be there. So once power is generated, it has to be transmitted. And we all know that transmitting at high voltages will always reduce the power loss. Why? Because P equal to VI cos phi. Okay, so tomorrow I'll just explain that bit regarding the voltage, how the increased voltage is going to reduce the effect of power loss. Today it's just a general outline, that's why I'm not going into that detail. But generally, we will transmit the voltage that is generated at 11 kV at very high voltages. So that is why we have this instrument called the step-up transformer in the generating station premises itself. So what it will do is that this is basically a transformer. So a transformer will have what? One primary side and one secondary side. So the input voltage to the transformer primary is 11 kV or 33 kV, whatever voltage at which the power is generated. And once it comes to this transformer, you can see here that it is a step-up transformer. So what will the transformer do? It will increase the voltage at the output side from this 11 to a very high voltage. It will be 132 kV, 220 kV, like that. Usually this stepped up voltage will be in multiples of 11. Okay, why? Because it is easier to create a turns ratio in that condition, because the voltage generated is 11 kV, and if the output voltage is in multiples of 11, that will be easier for us to step up. Okay, so then the stepped up voltage at 132 or 220 kV is carried by this kind of transmission wires, and there will be, in the transmission network, there will be a primary transmission side as well as a sub transmission side. And once it reaches to the consumer, near to the consumer premises, from there the distribution will start. Like I told you already in the previous slide, we are coming here, we are the consumers of 230 or 415 volt of power. Okay, but these type of consumers are the industrial consumers who will require power at 11 kV. So what they will do, here at here the voltage that was coming was 132 kV. So all this 132, it will come here, and then there will be a primary step down. So the primary step down will convert the 132 to 66 kV. Okay, and from the 66 kV, the industrial customer needs only 11 kilovolt. So here one step down transformer will reduce that to from 66 kV to 11 kV. Okay, and then again this 11 kV from the step down transformer goes to the domestic consumer. So the domestic consumer wants the voltage at only 415 or 230 volt. That is why This is called the secondary distribution transformer. So here what they will do, they are going to step down the 11 kV to 450 or 230 volt, and the 230 volt will come directly to your house mains. Okay, clear everyone? Clear? Can you just, okay, fine. Prithviraj has typed in, okay. Anyone has doubt? Okay, I hope it's fine for you. Okay, so regarding why we are stepping this up to this high voltage and all, that will depend upon the power equation connecting power, current, voltage and power factor, which we'll discuss in detail in the next class. This is just a general overview. Okay, so basically, just to recap this once again, this is the generating part, the transmitting part, the distribution part, and finally the end consumers. These are the 4 stages of a power system generation till the power system final usage at the consumer. Okay, so this up till here it was just to give you an overview of the power generation system. Now, the sources from which electricity is generated, that is, if you can see here, this red part where the generation is taking place. So the power generation, it will be, if you see this part represents the power plant in which the electricity is being produced. So generating station will have what? Basically a generator which converts mechanical energy into electrical energy. So this, depending upon the type of input to this generating station, we can decide what is the type of generating station we are using. That means like I told you, the input will always be some kind of energy providing source, and the output is definitely the electrical power that is produced. So what will be the input to the station? That decides what type of power generating station you are having. So generally, conventionally, the most common and the most widely used in general condition is the hydel power plant. Hydel power plant, the input is always water. That means you have a turbine, the dam, everything. So water falls from a height, turns the turbine, and turbine is connected to the shaft of the generator, and from the generator you generate power. That will come across in the next slide. So in the hydel power plant, the input to that is water. So that is a conventional source. Now we have the diesel power plant, thermal power plant, and nuclear power plant. These are all conventional sources of power. And for here, all you will see there is some, I mean, especially in the diesel, thermal, and nuclear power plant, it is not eco-friendly, right? Because the kind of, we are using up all the natural resources for generation of electricity. Like nuclear power plant and all are very efficient, but if you know that it has its own potential health risks and all associated with it, right? So that is why, since we, all these things, that is solar energy, wind energy, tidal energy, biomass and geothermal energy, we are getting it free from nature. So these are all the non-conventional sources of power, or the eco-friendly sources of power, which can be an input to the power station, and we can generate the electricity as the output of the power station. So solar power stations, I think all of you, and wind also, you'll be mostly you'll be familiar with these things. We will not go into detail into all of these things. Just we'll have only an outline of what each one is doing, because basically the idea is to know what all are the available sources. That's all. We don't have to go into detail in each one of that. So what I explained earlier, alternator is nothing but an AC generator. So every power station, irrespective of the input to the power station, will have mainly 2 components. That means there will be a prime mover and a generator. So if you see the RYB, that is the output of the generator, or what is the output? The electrical energy that is produced. So for the AC generator to produce the electrical energy, there should be some input. So if you see, this is representative of the shaft of the generator. So the shaft of the generator is connected to what? A prime mover. Prime mover is in the hydropower plant. Obviously the prime mover is your turbine. So, and the energy from sources, that means what is the input energy source? Like I told you in the case of the hydropower plant, we can take this case typically. So now we have water at a height. So water from this height will flow and it will come and turn the turbine, and the shaft of the turbine is connected to a generator. So what is doing? The shaft of the turbine starts rotating when water hits it, and the shaft that is connected to the generator will allow the generator to generate power. And like I told you already, this is a step-up transformer which steps up the 11 kV voltage from 11 kV to 132 or 220 kV transmission voltage. Like if you see here, this one. This transformer is the same thing as this. Okay. So here, this is a hydroelectric power plant where water is the input, and the and if you see this term prime mover, here you can understand the prime mover is the turbine and the generator is same as the alternator. Okay. So this is just a picture of the generator that is inside of a generator that is used in a typically hydroelectric power plant. Okay. So now the second thing, the traditional or conventional source of power is the thermal power plant. So in thermal, if you see here, water is the input source of energy to the power plant. But if you see in the thermal power plant, the input source is the coal. So when the coal is supplied into this, it is passing through the conveyor belt and the coal is pulverized. Pulverized means crushed. Okay. So here, this is used to boil the water, and the water is in turn used to, water when it boils, the steam is generated, and this is used to turn the steam turbine. And here the steam turbine is the alternator, and the alternator is connected to the shaft of steam turbine is the prime mover, and the prime mover is connected to the shaft of the alternator or the AC generator. So if you see in this process, you are supplying the input resource as coal, but you can see that a lot of energy is getting wasted in this process, or you can say that while the crushing of the coal is happening, lot of ash is produced. You might know this fly ash bricks and all that is produced from this wastage only. So this is the principle of the thermal power plant. Why we call it thermal power plant? Because it uses the coal and the heat energy supplied to generate electricity. So now the nuclear power plant, as we already know, it is very efficient or effective. So you have basically the nuclear reactor and the turbines and all those things. But as we all know, there will be some health hazards which are associated with the nuclear power plant. And next coming to that is the diesel power plant. Diesel power plant, obviously, again, the input to that is diesel. Now, all in this traditional or conventional sources of power, we can say that a natural resource is getting used up. Of course, the hydro power plant has got the least environmental impact, but all the others, they are not sustainable sources of power, or you can say they are not eco-friendly sources of power. That is why basically we are thinking nowadays of solar power plant, this wind power plant, everything. Okay. So now coming to the, so that is with mostly with respect to the generation part of the system. Now coming to the transmission part. Now what is the basis, what are the basic components of transmission system? Definitely, like you can see from, if you go back to this image here, you can see here, this is the truss which you see generally at roadsides or when you travel and all, you can see this. So these are just the support structures for the conductor line. So basically they should be conductor lines to carry the power from its source of generation to the source of consumption. So the transmission lines, what you have here, will have the conductors. Then there will be insulators. So in this case, you can see these are high voltage transmission lines. High voltage transmission lines from 11 kV and all are not going to have their own insulator around the transmission line. Rather, there will be insulators mounted on these trusses. You may see that on the roadside lines itself, like just a second, I'll see if I have an image. Yeah, if you can see this black disc on the side of the truss, that is the insulator. Okay, so basically it will be a support structure, a conductor, insulator, and protective equipment on either sides for protection against over voltage, over current, and any other fault that is happening in the power system. So, and also there will be voltage regulators, because when it gets transmitted, there will be a voltage, there should not be any voltage dip at the end of the supply, I mean at the end of the chain where the power is being consumed. That is why we have voltage regulators. So these are the basic components of a power transmission system. Okay. Now coming to the distribution part. Like I have already told you, there is the primary distribution as well as the secondary distribution. Now this primary distribution lines carry medium voltage power to distribution transformers. So the distribution, what you see on the roadsides and all, you will see the transformers which are mounted on concrete platforms, or which are pole mounted and all. Those are actually the secondary distribution transformers. So whatever you see in your residential areas or near your commercial complexes, that are all secondary distribution transformers. And the primary distribution, mostly you will not be able to see where it is happening, but it will be that is also another stage, the first stage at which the voltage is stepped down to a lower value, maybe to 66 kV. So this or maybe directly it can be to 11 kV. That is dependent upon the power structure of the system, where or the power network, where the voltage level will at that point will depend upon the power network which is being utilized. Okay. So, and again in the distribution, in the transmission part, I told you the okay. So in the transmission part, I told you, you have the components as conductors, support structures, insulators, voltage regulators, and protective equipment. So likewise, in the distribution side also, you will have protective equipment, step down transformers. Why we are telling step down transformers? Because the voltage that we are using at the distribution side will either be 11 kV or less than that. 11 kV by industrial consumers and 400 or 230 volt by the domestic consumers. So it will always be a step down transformer that is there at the distribution side. And then the bus bars. So why do you use bus bars? Because you have to branch out the power from one single source to individual customers. That's why we'll be using bus bars. So we'll go into lot of depth in the coming classes regarding the part of the distribution system. This is what I'm giving is just a general outline. Okay. Okay. So now coming to the utilization part. Now, who are the utilizers of power? The utilizers of power are the either the industrial consumers or the people who are using the electrical power for our homes or commercial complexes or whatever, depending upon the need. So, electric power, the main use inside any building will generally be lighting. So electric heating, it will occur maybe in your consumer premise, I mean in your houses itself, like maybe in colder countries, you will have the electrical heating inside the house, or welding. Welding is just anyway from the industrial side only. Electrolytic process, that's again another use by the industrial consumers. Refrigeration and HVAC, that everybody, I mean we also, domestic consumers also will be used. Electrical drives will be there in industries. And electrical traction, it is exclusively for the movement of the trains, that is in the traction substations and all which you see there. So, and it's again the same thing, the train movement. So these are the major areas where we are utilizing electrical power. Okay. So is that clear to every one of you? Yeah, can you just type in okay or something if I can proceed, or if you have any doubt, just type that in the chat box. Can you explain transmission slide once again, ma'am? Okay, so fine. So like I already told you, this is the area where the transmission is occurring, or more clear in this. Prakash, if you see the blue color part, that is where the transmission is occurring. So like I told you, the voltage is generated at 11 and stepped up to 220 or 132 kilovolt at this generating station itself with means of a step up transformer. So once this come to transmission, why we are stepping up to a higher voltage? It's because the power loss is less when the transmission occurs at higher voltages. So we transmit this from the point of generation to the point of distribution. So here in this transmission, what are the main components that will carry the current from the supplier to the distributor? If you see in this blue color sketch itself, you can see the support structures. Support structures are nothing but the ones which you generally see, this truss, steel trusses that are used for carrying the conductors. Okay, and also from transmission, you have the main thing is the electrical lines or the conductors which are supposed to carry the current. Now, if you see in higher voltages, that is 11 kV cables and all, these are all higher voltages, right? Above 11 kV or maybe 11 kV. This is definitely more than 11 kV. So these higher voltages will not have the insulation covering around the cable. These are just bare conductors. So what is actually acting as an insulator in this case is the black disc that you see here, this thing here. Okay, so these are the insulators. So the transmission, the overhead transmission line has the conductor, the insulator, the support structure. Now coming back here, okay, so here there will be protective equipment at ends as well as along these lines to protect it from fault condition. Okay, so that is what is mentioned here. So basically you have conductor, line insulator, support structure that we have already discussed. Now, protective devices are breakers, relays, lightning arresters, etc., which and all will come in detail in the next classes. But the transformers that you see here, like I told you, we are we don't want a 132 kilovolt at the consumer side, right? So we'll be stepping down this 132 kilovolt in between stages to maybe 66 kV or to 11 kV, like you have seen in this slide. Okay, you can see here, right? The step down transformer steps down the voltage from 132 to 66 kV. And here again there is a step down transformer that will step it down to 11 kV. Okay, so these are all the step down transformers that are occurring in the transmission system. Why? Because this 132 voltage is the voltage we are transmitting, and by stage we are going to reduce it so that finally the consumer will get it only at 11 kV or 415 volt. Okay, and voltage regulators, that is the final component of the transmission system. Voltage regulators means these are equipments that are used to keep the voltage at this. I mean, if you want 11 kV at the end of the consumer side, it should be 11 kV, not 10.8 or 10.1 or something like that. That is the concept. So at the receiving end, the voltage should be within the permissible tolerance limit. That's why we are using voltage regulators. Now, one thing just I forgot to mention. So far, what we were discussing is the overhead transmission line. Now, there can be underground lines also, which will be there in cable trenches or cable ducts that will be carrying the conductors. This also, again, we will discuss more in depth later. But these are the basic things which regard to transmission, distribution, utilization, and generation. Okay.
Okay.
Okay. Fine. Prakash, is you still have any doubt? Is it fine for you?
Fine, ma'am. Thanks a lot.
Hello.
Yeah, fine, ma'am.
Prakash. I can't hear you.
Yes, ma'am. I can hear you.
Sorry.
Okay, you can't. Okay, I got it. It's clear
You
now.
got it. Okay, okay. Any problem, just let me know. Once again, I can explain no issues. Okay?
Yeah, sure.
Sure. Okay. So, okay, so that is with regard to the introduction part. You want me to continue with the next slide, or tomorrow we'll take it? Sir, Dharma sir is there?
Yes, madam.
Sir, today that
Yes,
introduction part only that I have finished already. So that next slide onwards, shall I take tomorrow, sir, or you want me to continue today itself?
Yeah. You can take tomorrow, madam. No problem.
Okay, because
Dear
I
team,
was thinking
anybody
I
have
can
doubt
write
on
it
this,
down
you
and
can
show it
ask.
to them.
Otherwise,
Okay, no, doubt that they said it is clear so far. Hello, sir.
yes, ma'am.
Okay, sir.
Then
So,
let me today finish the class, madam.
okay, sir. Okay, fine.
So, you see somebody asking question, madam. Arun Kumar having one doubt.
Arun Kumar. Yeah, Arun, can you unmute and ask? That will be easier. Hello?
Can you hear me, ma'am? No? Can you hear me, ma'am?
Yes, I can hear you. Tell me.
Ma'am, can you just explain about the bus, ma'am?
Bus duct?
Bus bar.
Okay.
Yeah, bus ducts. Okay.
Don't worry, that design and all we'll go in detail. Just only what I wanted to tell you is that the purpose of a bus anywhere, whether it is the distribution or inside the panel board or anywhere, it is just to branch out the electricity that is coming from one point to multiple sources. Okay.
Okay, ma'am.
Okay.
I'm getting it.
Getting it. Okay, just I'll show you
Yes.
one small example from Google.
Okay.
I mean, it is what the kind of a bus bar that we are using.
Okay.
Inside the, just to show you the purpose of that, that's all.
Okay. No.
Okay.
Yes, ma'am. Ma'am, and one more doubt, ma'am.
Yeah, tell me.
Ma'am, underground lines, ma'am. About underground that cables.
Yes.
In how much depth they will lay that underground cables?
Sorry.
In how much depth, ma'am? Like
That will that is depending upon the standard and all.
Okay.
Usually we have that definite standard for that. That will come in detail in the next class. Don't worry.
Okay,
Just
sure.
an outline of that. That's all.
Okay.
Okay. So just to make that bus duct concept clear to you. So. Okay, so here, oh, sorry. I'm just looking for a clear image so that. Okay, Arun Kumar.
Yes, ma'am.
Hello, Arun.
Yes.
Yeah, just showing an image which will be little clear to understand. Like there will be a common metallic structure. I mean, like a common conductive structure, maybe copper or aluminum. Okay.
Okay,
like this. Okay, this is just a single line representation of that. So
okay,
if you see the power that is coming from here, you see that branches which are being taken out, right? 1, 2,
Yes.
3, 4, 5, 6. Basically, if you see the idea of having a bus bar is only that one. That is to distribute it into subways.
Okay.
Okay. So if why it is coming prominent here is here if you see, right?
Yes, ma'am.
So it is like a branching out to various people.
Okay.
Okay, that is the concept. So from one point, the power that is coming and individual users are there. So like this, if you see, these are all individual connections. D1, D2, D3, D4, D5, D6, D7, right?
Ma'am, I
I mean,
can't
this is
see
not
the
the
screen.
exact.
No, I can't see the screen.
You can't see?
No, I can't see the screen. Like you are just taking the image from the Google and you are showing it, or it is from the slide, ma'am?
Sorry?
You are just taking the image from Google and showing it to me, or it is the image from the slide?
Bus bar thing is the Google image. The whatever I
No,
showed.
no, ma'am, I didn't see the Google image.
You cannot see. Others also can't see.
Yes, Prakash also can't see.
No, we didn't see the
Nobody
Google
see
part.
your Google part, madam. This is visible.
Okay. Fine.
You can share that one.
Oh, that doesn't come. Okay, I didn't know. Sorry.
Oh, no problem. Take your time.
I'm so sorry. So okay, I'll download it and send it to you.
Okay, ma'am. Otherwise, no problem. You can just take the picture. You can tomorrow also.
No problem.
Okay.